Hi, thanks for tuning in again today. Diagnosis of the charging system 503, 582, whether it has a blue regulator or it uses the standard Rotax regulator. I'll show you how I test these systems and get quick results of where the problem is. Now, before we get into a deep dive on our charging system and do a lot of diagnosis only to find out the battery's no good, let's look at the battery first. Now, depending upon what kind of battery you have, is going to depend upon what kind of a charger that you need to use for it. A lead acid battery charger, like your old fashioned battery charger kicking around out in the garage, it may not be correct for the type of battery that you have. So if you have something, check the instructions on any of them, but if you have something other than a lead acid battery, I recommend that you check the manufacturer, say Odyssey, find out their charging procedures, what kind of a charger to use, because if you use a lead acid battery charger on the wrong kind of battery, you'll probably damage it, and then you're no further ahead than you were. Now, once it's charged, how do we know if it has any power, any capacity in it? This is a very inexpensive little meter that's a load tester for batteries. It's a car device, but you can adjust it down to, like, say 100, 150 amps and do a battery test, load test on your little small airplane battery. So these are pretty cool. And don't forget, you got to have the right charger. So here we have our stator. There's the green poles on it. It has copper wire wound around each one, and the yellow wires come out. So let's come out through this harness that comes from the crankcase. So let's simplify this and make a drawing of exactly what's there. So we have our 8 poles here, and then we have a wire that comes in from right at this junction and goes around to the next, around to the next, all the way through. It's one solid wire. And over on this side, this end of it is connected to the yellow wire, which goes through that rubber harness. So there's our one wire, which is all solid yellow. And at the other end, we have a junction here, and we have the other wire that's yellow and black. This is where the AC voltage, we want to measure the AC voltage. So how does this actually produce any AC voltage? Well, I have my representation of a magnet. They go all around the magneto flywheel, and it's rotating. And as the north-south pass, they induce a voltage into each one of these. And this is, so we're going to have AC voltage that comes down the yellow wire, and AC voltage we can measure right here. And at the other end, of course, we can measure right there. Now, to do this test, this is an open circuit test. So we have the connector that this plugs into. This is the aircraft, and we've disconnected it. So we're not attached to the aircraft at all. We've disconnected these 2 wires, either from the regulator or right from the harness at the engine. And this is where we checked it. You want to check all these connectors to find out if they're corroded inside. You never know. They could be burned inside. Once in a while, I see a connector on the small white ones that's melted inside. So it has a connection through one wire, but not the other. How we'll do this is, now that it's unplugged, we'll from the airframe, we're going to connect to the yellow wire, the yellow and black wire with these leads, tape them up so that they don't short. At the other end, where we make our connections to our meter leads, also make sure that they're taped up, they're insulated so that they don't short out. And we need to always be aware when we're around aircraft, especially when you're doing this test, because the engine is running, the propeller is spinning wherever it's attached to the engine. If you're not 100% comfortable doing this kind of testing on your aircraft, please don't do it. Have a professional come. It's not worth the risk. So if you decide you're going to do this yourself, don't forget the engine's running, the propeller is like right there spinning around. Don't get injured, please. To test this, we will use our voltmeter on AC volts, and we will get a reading as far as how many AC volts it puts out. So we're going to move over to my ignition test center, and we're going to get a voltage reading on it. I'm using the auto range meter, and I'll be using the 2 jumper wires. They can be any color. I'm going to make my connections right here. So this is the yellow and the black wire, and this is the solid yellow wire. It doesn't matter which you put on. If these are black, white, doesn't make any difference. It's AC volts. So we'll go down to the other end of the jumper wires, jumper leads, and I'm going to connect them. Again, it doesn't matter. We're working with AC volts. So let's set the meter to the correct scale. So just as a review, if you don't know how your meter works, check the instructions and learn how it works. The V right here for volts with the straight line and the 3 dots under it, that's for DC volts, so plus minus, like your airplane battery or your car battery. We want AC, so we want volts with the little sine wave on top of it or beside it. So there we go. We've selected our see, we have the sine wave there. So we're in AC volts. We're connected here, and we're connected at the other end to the stator charging wires. So let's start this up, and we'll just start it up. It's probably set for 2,000 RPM already. So yeah, 2,000 RPM. We have 24.5 volts. So let's speed it up a little bit more. So you'd accelerate the engine up to 3,000 RPM. So 3020, close enough for what we're doing. And now we see we have 36 volts, 2528. So we'll just use the whole volt. So 36 volts at 3000. Let's run it to 5,000 now and find out what we get up there. So right on 5,000 RPM, 60.33, so 60 volts. What results did we get? Voltage AC. At 2,000, we got 24 volts. 3,000, we had 36. 5,000, we had 60 volts AC. Now, as you can see, as the RPM increases, of course, so does the voltage. Why? Because the magnet's going in a circle around it faster. It's just the way it works. Now, if I had these numbers, I see these numbers, this is absolutely perfect. Any good stator will put out this kind of voltage. So is this good at idle? 24 volts? Yep. At 3,036, at 5,060. So the stator gets a check mark. It is good. So my drawing deals with this blue voltage regulator. And they made it really quite simple because they've got 2 yellow connections on it. So our wires are going to go from each one and connect up to the regulator. Now, what are we going to find in the harness? is, of course, we're going to have a connector up here. And you never know where the regulator is going to be. We could have a connection here. So just because the wire is physically connected doesn't mean it's electrically connected. So have a look at all of these connections and make sure they're not corroded and they're actually connected electrically and not just physically connected. Now we move along here. The black one, of course, is negative. It's going to go to the battery, and the positive that's going to go to the battery. What else should we have? I would recommend that this has a ground on it to the airframe. So here's a ground. So this will go to the airframe, and eventually it'll make its way, of course, through the airframe to the negative of the battery. Now let's look at how we would wire this Rotax voltage regulator. This one's a little more interesting. And of course, all the information in the schematics for this is all in the Rotax manuals, but some people may have a hard time to understand this. So let's go over it. So what are we going to do here? We have the black wire that comes out. Well, you might think, well, maybe that's ground. No, it's not. The black wire is actually the red wire that would go to the positive of the battery. So how do we get to the negative of the battery? Is we have another wire that we put under one of the mounting screws, and it goes to the negative of the battery. It's critical it has a good ground and these connections are proper. There'll be a fuse in between. We'll get into that after. So now we've got 3 wires left. How are we supposed to hook this up? How do we connect it? So we'll just go from the 1 wire to that connection, and from the yellow and black to that connection. And again, we have connections that we need to always be checking. Are they good connections? Do we have a good contact? Now, what do we do with this leftover wire? Well, we don't do anything with it because it's not required. This is a 3-phase regulator and we only have 2 phases hooked up here. So this wire, we just need to make sure that it's protected from shorting out. So this wire, we're not using that wire at all. So let's take the circuit a little bit further now and add the battery. So we'll do this. And we're going to connect the battery through the positive wire. I made it red here, but remember it goes to the black on the regulator. And then there's going to be a fuse. So this will be 16 amps. This fuse that's here. It's very important that it has the fuse there. Now on the negative side, what do we want to do? Well, we want to say we're going to take this to the airframe. And here's the airframe right here. Then we'll go from here over to the negative of the battery. So this is the airframe here. Or sometimes I've seen them also connected where they've just run it directly so that there can't be any issue if there's some connection in the airframe somewhere where the airframe is eliminated, and we're just going to keep it real simple and we just go right from there right to the battery. So that completes that part of the circuit, whatever way that you want to do it. If you maybe you think that there's, you know, there could be something, it's on a riveted plate on the airframe and it may have a bad connection. If you want to eliminate that issue, just go straight to the battery. We want to keep the charging system separate from everything else. So connections, connections, connections. So there's a connection here. There's a connection at the fuse. There's a connection at the battery. Connection at the battery on the negative side. Connection there to the ground. We want to make sure that all of those connections are proper. They're clean. They're not have any corrosion on them at all. But once in a while, they run into a case where I'm not the voltage regulator needs to be able to sense the battery voltage to be able to work correctly, to charge the right amount, not overcharge, not undercharge. How can this get messed up? Well, say we have some type of an accessory that we're decided we're just going to put it on this wire right here because it's handy to access. So we're going to tag it onto this wire right here, and it goes off and runs whatever the accessory is. This charging system is not going to work correctly because it cannot sense the voltage here when something else is tagged into the circuit on the way. So it's critical that if you're looking, oh, maybe it's an airplane you just got, or you're looking for an issue, you need to make absolutely certain that there isn't anything jumpered in to that positive wire, or for that matter, on the negative side, on the ground as well. Let's take this to the next step now. So we have whatever accessory you want to run, be it a light or whatever, it doesn't really matter for what we're doing here, but some type of a load. And that load should be connected how? Well, I would like to see it come from the positive of the battery and come around here to the positive bus bar, and it needs to have a fuse in it. And it's going to connect onto the positive bus bar, and the negative is going to come across from the battery to the bus bar. Then we'll go from one of the terminals into our accessory, and then positive to our accessory. Now what happens when we do it this way is when we have a load over here and put a load on the battery, the load's coming right from here, from the positive and negative, so that the voltage, the regulator will see a drop in the voltage when we take power from the battery to run our accessory, and it's going to go, okay, need to charge the battery. And this is a way, if it's connected as in this circuit here, it will work without any problems. So now the schematic is here. Let's find out and observe how this actually works. So we're going to go over to the ignition center here, and I'm going to connect a regulator, and we'll do some voltage testing with it, and you'll see how it actually operates. So here we are, we're all connected up. Right, we're on our yellow and black. The two yellows that go into the regulator, the black is hooked up to connected to the red, which goes to our positive with a fuse. And the ground, negative, is hooked up to the regulator. So we have a complete circuit here. So we're going to do this testing in DC volts. So remember, DC volts, that's the one with the line with the 3 dots under it. So we're going to select it into DC volts. And now we're going to start this up. It should be around 2000. Make our connection at the battery, negative, positive, 12.61 volts. Isn't that what we started with? Yeah, this is not working. It's just battery voltage. It's just running off the battery. Okay, why is it not working? Let's find out. So let's do troubleshooting. These are mechanically connected, but are they electrically connected? Let's check and find out. So we're going to use the ohms setting, which is the horseshoe omega sign here, ohms. And when we push our 2 leads together, this is 0.2 is actually 0. So whatever we're going to get, if you want to be super accurate, take off 0.2. So let's start with 1 and get it right over here, right on the connector. Might not be able to see it, but I'm right on the connector. One of these should be connected. That one. So there is a little bit of resistance, but no, I have an electric circuit there. Let's go on the other one. And I have an even better circuit there. There can be a little resistance in these test wires. So that's connected. So where else could we go wrong? Well, let's go from our positive to the positive here. We have really, that's a good jumper wire, 0.01. So there's no resistance there, but we have a fuse in here. So let's go to the other side of the fuse and we're open. See, that's closed. When we're open, that's giving us, there's nothing. So this fuse is blown out. So this is why you need to be doing some basic checks, and you can figure it pretty quick. Well, this one was not charging because the fuse is gone. So let's put a fuse in it. Now, the other thing is it the correct rating? It should be 16. And, oh, this fuse is not 16. So it's no wonder it burned out. It had the wrong fuse in it. So let's put a 16 amp fuse in it, and then we'll test again. All right, I went and found a fuse. So we're going to put the correct amperage fuse in it. Put the cover back on. Well, let's test this again and see. So here we are from here, right to there. Look at that. Now we have a circuit. So we know that that new fuse we put in is actually a good fuse. So let's start this. Now we're going to switch back. Sorry, we're going to switch back from ohms because we're finished that troubleshooting. We're going to go to volts DC, right? The line with the 3 dots. So we're running at 2600 RPM, and let's take a voltage reading. So we'll go on the negative of the battery and the positive of the battery. We have 13.91. So that's really close to 14 volts. I would take that. We're just above idle. It's charging perfectly there. So now we're at a much higher RPM, 4,800. So let's test again. 13.89, 13.9. No problem whatsoever with that. So the voltage regulator is just sensing the battery voltage. I don't have any accessories hooked up to it. So I'm going to go get an accessory and connect it to the battery, just as I was talking about in the diagram, and let's find out the difference that it makes. So I have the, I'm at 3,700 RPM right now, and I've connected up this headlight here, and I'm running it through the amp meter just so that we can see how much amperage it takes to run this light. And I know it's getting to be a lot of wires around here, but what I'm doing right now is I've inserted the probes from the meter so I don't have to hold them. I run it with jumper wires, and I'm just going to apply the negative through the meter and make the headlight come on. Now, I don't know if you can hear it, but it slowed the shaft speed down on the machine a lot. It doesn't have a very powerful motor. And we can see it's drawing almost 3 amps through the light. So now let's get back to this other part of it. What's the voltage? So it's just under 14. I would take that, no problem. So let's put the 3 amps load on it. It's 1363. It's slowing the engine, the shaft down. If the airplane was running, better turn it off before it overheats that. If the the engine was running, it makes more power than of course, well, that's pretty warm. Of course, that this little motor that runs this does. And so with 3 amps, it stayed above the battery voltage. Remember, it was 12.61. That's what we want. It needs to sense there's a load drawn off the battery, and then it will step up to the plate. And you heard the difference in the sound. It's producing a lot more power. So this is how this all works. So hopefully that makes sense to you. We'll move along to the blue regulator. So we have the yellow and yellow. You remember they come right from the stator output. So they're marked to the AC, they're yellow terminals. And then we have our red and our black. So red is coming around here out of the way, connecting to the battery through the fuse, and the ground is just connected right here, right on the battery. So that's what we got. Now let's just spin this up. So we're at 3,300 RPM. So we're going to go back and we're going to select our DC volts. And let's see what we have for charging now. 14.84. Well, that, to run at 14.85 volts, that's pretty high. That's going to be a little bit tough on the battery because the voltage is pretty high. So what can we do now to see if we can reduce that at all? So let's try a redundant ground on the housing. So I've put a ground wire on the housing. And let's find out if it makes any difference now that I've grounded this. 14.88. That's still pretty high. So this is a old voltage regulator that is charging too high. So I have another one, so let's try it. So now I've changed out to this other voltage regulator, and it's all connected up the same as it was before. So let's let the machine spin up. So 3,900. So let's check our voltage right at the battery. 13.9. Oh, that's spectacular. So 14.1 on the high side would be my high number. So 13.9, 14.1 would be considered perfect as far as I'm concerned. Now let's take our, let me push these guys underneath here, which, so there we go. So 1405, see, that's like perfect voltage. So let's take, remember our headlight here was 3 amps. So let's hook this up 3 amp draw, just like it was the bus bar. Remember, it's going to be hooked right to the battery. And so we see the voltage drop down. That's not a problem because now it's making more amperage. So it's sensed I'm asking for 3 amps. Now it's putting out 3 amps more, and the voltage is holding steady above the 12.6. So we're good. The battery must be, as far as I'm concerned, you're going to do diagnosis, perfect. So it needs to be fully charged. You need to test it to make sure that it is a good battery, because to do all of this testing and find out that you've got a bad battery, it's sort of, that's the first place that we should test the battery and make sure it's perfect. If you don't know, how to test it, you can't charge it properly, because some of these batteries take special charging procedures. They're not all lead acid batteries, and you may need a proper charger to charge your type of battery. So if you don't know, maybe just start with a new battery. You're trying to fix a problem anyway. So make sure the battery is perfect, and you'll get results just like we just had here. Now, if the system is wired up in this manner, what can we run as far as accessories go, or consumers is actually their correct term? How many amps can we draw? So this stator is not like the alternator on a truck or something where you could run 100 lights from it. No, it has a limited capacity. It puts out 12 amps. So that's the most that you're going to get from that. Well, what can we consume out of that? You should never consume more than 80% of your output in accessories. Why? Because there isn't anything left to try and put a charge in the battery. As you're flying along, if you're drawing 12 amps, it's really just running off the battery, and the battery's not going to be able to recharge. It's going to slowly deplete the voltage in the battery. So for our accessories, the most that we should want is 9 amps. And then that gives us 3 as minimum to put into the battery, to charge the battery. So then we can have full output from the stator through the regulator. We can be burning up 9 amps in all of our accessories, and we still have 3 amps left to put in the battery, and everything is good. We'll run the accessories, we'll recharge the battery, and everything will be nice. Now, how many amps that you draw, it all depends on what all the accessories you have. If you have, you need to go to the manufacturer's instructions on your glass panel, all these other things that you may have as accessories. Find out what the voltage draw, or the amperage draw is on it, and make sure that at any time you're not exceeding 9 amps. If you are, you're going to have nothing going into the battery, as I said, and the battery will eventually just deplete the voltage down, and you'll have a dead battery anyway. Not because there's anything wrong with the output here. The voltage regulator works perfect. The battery is perfect. You're just drawing so much off of it, there's nothing left to charge the battery. So I hope that makes sense, but that's the way it works. Well, I hope now, if you suspect you have a problem with your stator, now that you know in the simplistic way of how it works and functions and what you should expect for output, you can test it easily. Depending upon what voltage regulator you have, does it work properly? Is the whole system even hooked up correctly? Is there a load somewhere on that wire that comes from the voltage regulator positive wire to the battery? There should not be. So you might want to check that if you have an issue with it not charging properly. Check all the connections, make sure everything has a good ground. If this does not have a good ground, it will not work properly. And I would put a ground on this one too, just because I like redundant ground. For a little piece of wire, it's well worth it. So I hope you enjoyed the video today. Like, share, subscribe, all those other things. You got a comment, question, let me know. See you again. Bye now.